All right, so let me keep going then. So, right, again, when we're adding, you can see the exponents. Come on. Here we go, here we go. Right, you can see the exponents do not change. When we get to multiplication, they will change. Okay. Good. When we get to multiplication, they will change. Okay, so that was one example. Let's do another one. Here we go. Here's another fun one. So again, this is just another example I figured we do. We're adding polynomials horizontally. So again, same idea. We're trying to find the sum of this one and the sum of this one. So we're going to add these two together. You really don't have to put them in parentheses like I did here. I just thought it'd be easier for us to see, you know, visually what's happening. But now again, what do? We have to pick out the like terms and combine them. So we have 12x to the fifth, right? We're going to combine that with 6x to the fifth. These are like terms, right? Because again, the powers of x are the same. That's why we have this. And how do you add these? You just add the wonderful coefficients, and you get this thing, 18x to the fifth, 4x to the fourth, right? The like term here is minus 3x to the 4. You know, so again, we just combine those like so. 4 minus 3 is 1. And you keep on going. Notice that there's no other term here in the form of x cubed, so we leave this alone. Same thing for the squares, right? Like terms, you combine them, and so on. Notice the answer here is in standard form. Okay, you know, that's when the powers of x go down. So that's just another example. Okay, now I'm going to demonstrate how you add polynomials vertically. I did write the method there. The whole idea is, as you'll see, it's really easy. It's really not that bad, actually. It's a little more visual. The whole idea is what you're going to do. You're going to put like terms in the same columns. I mean, I do have the method here, and the notes are available, so I'm probably just going to pass over this. I'm going to demonstrate it using an example. Okay, so here, let me do this. Okay, so what we have here is we're adding two polynomials. Notice what I did was the second polynomial, right? I put it on top up here, as you can see. Right, that's on top. I made these columns here, like you can see. And in the columns are going to be like terms. So from the first polynomial, the terms that are like terms are going to go in the same column. Does that make sense? Be honest.
Yeah.
Honestly? Okay.
Yeah.
Okay. But basically, that's what we're doing here. The whole idea here is, I probably should have done animations or something, but the polynomial with more terms, since we're adding, you could put that on top. You keep the negative sign with any terms. That's actually what I say here. You put the terms in the second polynomial. Well, actually, it really doesn't matter which one. So that like terms appear in the same column. Okay. You keep negative signs. That's what I'm saying here. Notice also I put zeros here as placeholders. I mean, you really don't have to do that. I personally like to do that, right? Because there's no terms here of degree 4. So I put zeros in as placeholders. And since we're adding, we're going to add these things. Okay? So we have this. And then we combine, we just add. So we have x to the 4 plus 0 is x to the 4. X cubed plus 0x cubed, right? That's just x cubed. So the terms in this column, right, they're like terms. So we have minus 5x squared, 7x squared, excuse me. We combine them, we get 2x squared. negative 3x and 3x, right? You combine them, you get 6. 5 and 1, combine them, you get 6. And this was the same answer. I think we actually did this one by adding horizontally, and we got the same answer. So again, it's really the same idea. It's just, I think this is a little more visual. So, okay. I mean, that's one example. Again, the whole idea is you're going to make these columns. One polynomial is going to be the top row, so to say. And the other polynomial goes in second. Like terms go in the same columns. And keep the negative signs with the terms. And you can use zeros as placeholders. So that's one example. Here's another one. So again, the polynomial with more terms, I like to put on top because we're adding, so you can add in any order. With subtraction, you have to be a little bit careful. Right, so that's what I'm doing here. So this goes in a column. This with its negative, that's in a column too. This here, right? That's in a column. Notice there's no x cubed term, so I'm using 0 as a placeholder. Minus x is in a column. 10 is in a column. And over here again, this is the other polynomial. This goes below, like terms in the same column, as you can see. Right, we're using zeros as placeholders. I think I made a mistake there, didn't I? Yeah. Yeah, I think I made a mistake on the slide, so the answer's here I gotta fix. But I mean, so the answer is wrong, I gotta fix that. But hopefully you got the right idea. At least I hope so. Oh, wait. That's with adding. And with subtracting, really it's similar. When you subtract though, wait, let me get the pointer going. Here we go. With subtracting, you do have to be a little bit careful, right? Because you distribute that negative sign. That's why I like to put parentheses around the polynomial you're subtracting, right? We're subtracting this one from here. So we're subtracting this one, like so. I put parentheses around it. And we have to distribute that negative. That's what I'm trying to show you here. Okay, as you can see. And now we combine 12x cubed, right? We have 12x cubed. Excuse me, there's no x to the 4 term here, right? But we have one here, so that's going to go here. The 12x cubed, right? Are there any terms just like x cubed? Well, yeah, we have a minus 4x cubed. 12x cubed minus 4x cubed, that's 8x cubed. I mean, I put both of them here next to each other. We have minus 3x squared and 2x squared, right? That's over here. Again, you just want to put like terms next to each other. One negative one like so. Here, because of the negatives, you want to be careful with these. And when you do that, this answer. Let me get my. There we go. Okay. The idea is not, it's not that much different than adding, except with the negative here, you have to distribute it. That's all. And you can use either method. You can use this horizontal method. I also have the vertical here. Oh, same one. Right, it's the same idea basically, but here you do have to be a little bit careful because with subtraction, you know, order does matter. So this one here has to stay on top. And notice also I use zeros as placeholders, even though for x as well, that's a so-called intermediate term or middle term, I guess, if you want to call it that. I put a 0 there. This is on the bottom, so I put on the bottom, like terms must go in the same column. And now you can subtract, like so. Notice also, I turned this into addition, but the negative I distributed. which is actually the same thing as for the horizontal method. You know, you distribute that negative, and that's what I did over here. And after you distribute it, then you combine the terms, which really means in a so. Yeah, this answer, I don't know what happened. I'll fix these notes and I'll repost them. So, but I really hope at least you get the idea. So let me just minimize this. So, I mean, so we have, what do we have, like a minute or two? Yeah, we have like 2 minutes left. Are there any questions at all?
No.
Not really. I mean, how do I say this? Whatever method you prefer, you can use on your own, horizontal or the vertical method. I mean, I hope I explained it well. Again, I'm doing this online, so let me stop sharing. Okay. So let's see. We have like a minute left. So I figured I'll stop now. And then that breakout thing I tried to do, what I will do is post a worksheet. And then next time you guys can work on it in class, you know, in the breakout groups. Okay?
Okay.
I figured we'd do that because I really want to try doing some kind of group work here because I hate to have you guys just listen to me the whole time. I feel like, you know, it's not as fun that way. All right. Wait, no. All right, so let's see, it's almost 12:50, so I guess we'll stop now, okay?
Okay.
Okay, and again, there's no office hours today, so, all right. All right, so have a nice day, everyone. I'll see you on, what do you call it, Friday.